Hello friends, how are you? Today in this video I am going to discuss about the orthogonal functions. Question is, what do you mean by orthogonal function? Answer of these questions you can start like this. In mathematics and physics, the term orthogonal functions refer to a set of functions that are perpendicular to each other in a certain function space, typically with respect to an inner product. What does it mean? So, first we have to understand formal definitions. Two functions fx and gx are orthogonal if their inner product means integral of their product is 0. You can see the bracket fx and gx is equal to integration a to b fx and g of x dx is equal to 0. So here f of x and g of x represents the inner product between the two functions fx and gx. Keep in mind. The limits a and b are the bound of the interval over which inner product is defined. So, intuitive meaning. Orthogonality of functions implies that the two functions do not overlap or influence each other in the context of inner product. In geometrical terms, if you think of functions as a vector in a multidimensional space, orthogonal functions are vectors that are right angles, means they have zero dot product. Example in different context. You can see in infinite dimensional space for a vector v1 and v2, they are orthogonal if their dot product is 0. So v1 dot v2 is equal to 0. Similarly, for function in a function space, orthogonality is defined in terms of an inner product. In Fourier series, functions like sine of nx and cos angle mx are orthogonal over the interval 0 to pi, because 0 to 2 pi sine nx cos mx dx is equal to 0. More generally, the basis set of Fourier series are orthogonal with respect to the inner product. Now, my friend, in quantum mechanics, in the context of quantum mechanics, the wave functions or eigenfunctions correspond to different eigenvalue of an observable operator are orthogonal. For example, the wave function for different energy level of quantum systems are orthogonal. You can see if psi n of x and psi m of x are functions for different energy state with different quantum numbers, they satisfy the conditions. So integration psi n star of x psi m of x dx is equal to 0 for n is not equal to n. Here psi star of x in the complex conjugate of psi n of x. Now, what is the properties of orthogonal functions? So orthogonality does not necessarily imply that the functions are normalized. If functions are normalized, they are called orthonormal. Two functions are orthonormal if they are orthogonal and each function is normalized. That is, their inner product with themselves is 1. So, bracket f of x and f of x is equal to 1. A set of function is orthogonal if every pair of distinct functions in that set is orthogonal to each other. A set of orthogonal functions forms a basis for function spaces, which is useful in expanding function in terms of these basis function as in Fourier series or wave function expansion. My friend, examples in the context of quantum mechanics. In quantum system, the eigenfunctions of Hermitian operator, you know the Hermitian operator, like the Hamiltonian, are orthogonal. For instance, the energy eigenfunction of a particle in a box are orthogonal. 0 to L psi star n of x psi m of x dx is equal to 0 for n is not equal to m in this condition. So this orthogonality is crucial for simplifying the calculation and ensuring the quantum states corresponding to different energy level do not interfere with each other. So in summary, orthogonal functions are functions that, when integrated over a certain interval with respect to an inner product, yield a result of 0. They are widely used in the mathematics and physics, especially in series expansion like Fourier series and quantum mechanics, where they ensure the different functions.